And so it comes down to this. Good morning, good afternoon, or good evening. You've made it through the honors section after this lesson. So let's see what we've got here. This is Mr. P signing in, doing our very last notes for the honors section of Secondary Math 2, Notes 3.11, Compound Probability. So the compound event is the union or intersection of two events. Overlapping events are events where have one or more outcome in common. And disjoint or mutually exclusive events are when two events have nothing in common. Okay? So the probability of compound events, if they overlap, okay? If they overlap, this is how you calculate the probability of A or B occurring. That is, if A or B happens, not A and B, A or B. If they're disjoint, it's much easier. If they are not overlapping events, then you just add them together. Otherwise, you have to take away one of the probabilities of their intersection. Why? Because when you do this using your formulas, you would accidentally count that twice if you didn't take one away. So let's start with disjoint because that's easy. You roll a six-sided die where there's 1, 2, 3, 4, 5, 6 is your outcomes. Roll a prime number. Well, that would be 2, 3, or 5. And event B would roll a 4. Now notice that these have no events in common. They don't overlap. The event of rolling a prime number and the event of rolling a 4 are disjoint. So the probability of prime or a 4 equals the probability of getting a prime number, 1/2, plus, because it's 3 out of 6, plus the probability of getting a 4, which is 1 out of 6. I should probably leave that as 3/6 so they have a common denominator. Jeez, Mr. P. Which is 4/6, which reduces to 2/3. You have a 2/3 chance of getting a 4 or a prime number. So the following events are disjoint. Mysterious event A, which let's go ahead and say an asteroid lands on your car, and the probability is 0.4. There's a 40% chance. And the probability B is that a bear eats your phone. That a bear eats your phone. These are disjoint, and so the probability of an asteroid hitting your car or a bear eating your phone is equal to 1 plus the other, which is 0.6, which is 60%, and so on. Now, if they're overlapping, you have to take away the and. So let's look at this. You roll a six-sided die. So all the possible outcomes are 1, 2, 3, 4, 5, and 6. You roll an even number, you could do a 2, 4, or 6. And roll a number greater than 3, you could get 4, 5, or 6. Now notice there's some overlap. There's the 4, 5. The 4 and the 6 are overlapping. So the probability of A or B is equal to the probability of A. And this is something we're going to need to be really familiar with in this lesson, plus the probability of B minus the probability of A and B. So the probability of A, because we don't know the probability of A or B, that's what we're trying to find. The probability of A is 2, 4, and 6. That's 3 out of 6. That's 1/2. Plus the probability of B is 4, 5, or 6. That's 3 ways out of 6. That's 1/2. But we have to take away the intersection, which is a 4 and a 6, which is 2 ways out of the 6, which reduces to 1/3. So we get 1/2 plus 1/2, which is 1. But we're going to subtract 2 6, which is 1/3. I don't know why I just did that. 1/3. And 1 minus 1/3, well, you could think of that as 3/3 minus 1/3, which is 2/3. There is a 2/3 probability of either getting a number greater than 3 or an even number. Very good. And you can actually see that if you count them up, right? Because you could get a 2, 4, 6, or a 5, which is 4 out of the 6 ways, which is 2/3. In a group of 21 students, 13 write for the school newspaper, 10 are on yearbook, and 4 are on both. So what's the probability of randomly choosing a writer from the newspaper or a member of the yearbook committee out of that group of 21? Well, the probability of, let's go, newspaper or yearbook is equal to the probability of newspaper plus the probability of yearbook. Take away the probability of that person being on newspaper and yearbook. So that means the probability of newspaper or yearbook is equal to the probability of newspaper, which is 13 out of 21, plus the probability of the yearbook, which is 10 out of 21, minus the probability that they're on both, which is 4 out of 21. Now, thankfully, these have the same denominator. So 13 plus 10 is 23, and 23 minus 4 is, wow, I'm really not trusting myself today, 19. 19 out of 21. You have a 19 and 21 chance of picking somebody who was on either of them. Very good. Okay. Using the formula to find probability of A and B. So an educational advisor estimates there's a 90% probability that a freshman in college will take either a math class or an English class, and an 80% chance that the student will take math, and 75% chance they'll take English, with the probability that they will take both. So again, our formula is this. The probability of A or B, or we'll say A is the event of English and B is the event of math, is equal to the probability of A plus the probability of B minus the probability of A and B. Now, it turns out this is the one we don't know this time, so let's see what we've got. The probability of A or B, there's a 90% probability that they might take either, so 0.9 is equal to the probability of A, they're going to take an English class, is 0.75, plus the probability of B, that they're going to take a math class, is 0.8, woot woot, more likely, I don't know, minus the probability of A and B, which is what we're trying to find. Do a little simplification. 0.75 plus 0.8 is 1.55. So 0.9 equals 1.55 minus the probability of A and B. Now, if I subtract, come on, there you go, 1.55 from both sides. Now, 0.99 minus 1.55, 0.9 minus 1.55 is negative 0.65. Don't worry about that negative. It's going to go away in a second. Negative 0.65 equals negative probability of A and B. Divide both sides by -1 or multiply by -1 or whatever it is you do to get rid of your negatives. And we find that the probability of A and B taking both English and math is equal to 0.65. There's a 65% chance of that occurring. You bring your cat to the veterinarian for her yearly checkup. The veterinarian tells you that there's a 75% probability that your cat has a kidney disorder or is diabetic, with a 40% chance it has a kidney disorder and a 50% chance it is diabetic. Your cat is messed up. And if they're finding all this out on a, how much space do I have to this problem? Okay. If they're finding this out on a checkup, y'all should have taken your cat into the vet well before it got to this point. So anyway, the probability of, let's go ahead and say the kidney is a problem, or what is it? Or your cat's got diabetes, is equal to the probability that your cat's got a kidney problem plus the probability that your cat has diabetes minus the probability that your cat has a kidney problem and diabetes, and you are about to need to take out a loan to save your cat. So the probability of K or D, there's a 75% chance. So that's 0.75 equals. Probability of there being a kidney disorder is 0.4. Probability of there being diabetes is 0.5 minus the probability of both. That is bad news for kitty kitty. So 0.75 is equal to, put those together, 0.9 minus the probability that your kitty has kidney problems and is diabetic. Take away 0.9 from both sides. So you get 0.75 minus 0.9. And I get negative 0.15 is equal to negative probability that your cat has kidney problems and is diabetic. And it's thankfully small. Divide both sides by -1. And the probability of your cat having a kidney problem and being diabetic is thankfully 0.15, which is 15%. Poor kitty. With that being said, it has been an absolute pleasure being your teacher. We made it through the whole thing, including the honor section. I have absolutely enjoyed the privilege of being your teacher this year. So thank you very much for this opportunity. Please let your instructor know if you have any questions. Please make sure you take your cat to their annual checkup. And if you think they might have a kidney problem or diabetes, please take them to the vet before their checkup. That's all I have for you today. This is Mr. P signing off, and I hope you have a wonderful rest of your day.